Section 11.1, Multiple Comparisons. So we've compared two groups before, and now what we're going to do is compare more than two groups. Technically, we could do 3 on up, but for the most part, we're going to just stick with 3. We might do some 4s, but these procedures that we will learn could extend on up, but we're just to keep the work manageable, won't do quite so many. So there's a very specific structure for this chapter. The response variable is always numerical. And for us, we're going to stick with means. So that's why section 11 comes right after chapter 9, because we're still talking about means. The difference is now we've done 1 mean and 2 means, and we're going to compare 3 means at this point. So here's our first example. It says, suppose we had bags of exactly 50 popcorn kernels, and we put different amounts of oil in the bags. Then we microwave each one of them for 75 seconds and recorded the number of kernels popped. The question becomes, does the amount of oil used affect the number of kernels popped? So we've got a data table over there where we have 2 different bags with no oil, 2 with a medium amount, and 2 with a maximum amount, and the number of kernels popped are recorded. We could do 3 completely separate 2 sample hypothesis t-tests because these are means, so they would be t-tests. The first one, we could compare no oil with medium oil and see if they're the same or different. And then we could do a different combination where we could do no oil with a maximum amount of oil and see what happens there. And then the last matchup we could do is medium with max, and we could see how that worked out. So that is right there is what a multiple comparison is. It's comparing multiple pairs of means. Okay, let's remember, what is the significance level? So remember that the significance level is the probability of rejecting the null hypothesis when it's actually true. And we usually set this to alpha equals 0.05. The problem with the multiple comparison method is that even though the probability of something going wrong on any one test is small, again, a 5% chance, when we do multiple tests, it creates more opportunities to mistakenly reject that null hypothesis. That leads us to the overall significance level. The overall significance level is the probability that we will mistakenly reject that null hypothesis at least once after doing several hypothesis tests. So if 3 hypothesis tests are performed, each with an alpha of 0.05, that overall significance level is about 14%. So if we go up and look at our original question here, what we're saying is if we set this one to 0.05 and this one to 0.05 and this one to 0.05, and then we do all 3 of them in a row, the overall significance is then 14%. So at that point, there's a 14% chance that we are going to make a mistake in at least one of those, maybe 2 or maybe all 3. The overall significance level is always larger than any of the significance levels for the individual tests. And the overall significance level increases with the more tests that you perform. And so by the time you get to 10 or more groups to compare, at that point your overall significance level is 90%. So at that point, if you're comparing 10 groups together, you have a 90% chance of making some mistake somewhere. So clearly there is a downfall to this, and we will talk about how can we compensate for that.